Okay, guys and girls, we will start from a very brief introduction, and then Avi will have about 45 to 50 minutes for your talk, and then about 10 to 15 minutes for questions, and then the formal part will be over, and those who want to stay can stay for additional 10, 50 minutes for the informal discussion, if it's fine with you. So it's my great honor to introduce Professor Avi Goldfarb. Professor Goldfarb is the Rotman Chair in Artificial Intelligence and Healthcare. Among other roles, Professor Goldfarb has served as a senior editor at the Marketing Science. He has published many articles in top journals, including Science, Management Science, Marketing Science. I thought about stopping here with all the science, but then I also saw the American Economic Review, Journal of Marketing, and many, many more. Avi is also a co-author of two excellent books, the more recent one being The Prediction Machines, The Simple Economics of Artificial Intelligence, which I personally recommend. And now, Avi, the floor is yours.
Okay, thank you so much, and thanks for taking the time to for the seminar. I appreciate it. I'm gonna share screen and we're gonna get going. So this is talk about AI and AI adoption. And with Rosina Ganavi, who just left University of Toronto, she's now starting her PhD. She was a pre-doc, she's starting a PhD at MIT. Mohsen, who just finished a PhD here in Toronto, and Ryan Webb, who's my colleague and is a neuroeconomics, but sits in the marketing department with me. And the starting point for this paper, as Yefim just hinted at, is prediction machines. So in prediction machines, we point out that all this hype around artificial intelligence that you're hearing is really about advances in computational statistics. Okay, no surprise to you guys, but we can think about this as a drop in the cost of prediction. And standard economics technology says when a technology does something fundamental that's a lot cheaper, we do a lot more of it. Okay, so starting somewhere around 2018, we saw this rapid drop in the cost of prediction. And how that played out was originally good old-fashioned prediction problems started to be used. We started to use machine learning. We started to use AI tools for. So for example, increasingly banks are using machine learning tools to predict whether someone's going to pay back a loan. Insurance companies are using machine learning tools to predict whether somebody's going to make a claim and how big that claim is going to be. These are arguably two of the most established prediction problems in business. And increasingly, we're using these tools that people call AI, machine learning tools, to predict whether someone's going to pay back a loan or someone's going to make a claim. But the history of the economics technology tells us that when something gets cheap enough, we start finding new applications that we might not have thought of before. And what's happened with prediction is that as machine prediction's gotten cheaper, we've started to realize that things like image recognition, vision, can be reframed as prediction. So that was the big transformation with the ImageNet around 2012, was that we can identify, label images using computational stats. And medical diagnosis is also prediction, right? What does your doctor do when they diagnose you? They take in data about the symptoms and they fill in the missing information of the cause of those symptoms. If you ask a doctor today, and especially if you asked a doctor 20 years ago, whether what they were doing was computational stats, was prediction, they would have said no. But very clearly it is, and increasingly we're using prediction tools to solve in these new ways. What OpenAI is doing is also computational stats. Okay, so ChatGPT is a predict the next word algorithm under the hood. And DALL-E is a predict the set of pixels that you're looking for when you ask for a particular image. So if you ask for an astronaut on a horse in the style of Andy Warhol, it'll give you something like this. This is different from a search engine. This is how to understand how the technology is different from what we had in the past. It's not that there's a bunch of images and it's finding the image most like what you're looking for. Instead, it has images of people on horses, images of astronauts, and images of the style of Andy Warhol. And it is combining those pixels to predict what you're looking for when you ask for an astronaut on a horse in the style of Andy Warhol. So under the hood, it's prediction, even though intuitively it may or may not seem like what we usually think of as prediction. These are new applications of predictions. Now, the arguably the central fact of computational stats of prediction is that predictions are uncertain. So we don't know for sure whether when we make a prediction, that's how things are going to play out. If it's a prediction about the future, or even if it's a prediction about the present or the past, what's going on right now, predictions have error. Okay. And so this has been, the common theme in popular writing and technical writing about decision theory, which is that when you have a prediction, whether it's a human prediction or a computational prediction, you have a best guess, that's your mean, your point estimate, but you also get a variance. And maybe if you can get moments beyond the variance. Okay, so these advances in machine learning are about prediction, and predictions are uncertain. But when you look at how most companies present their predictions, they're surprisingly confident. So the way machine learning tools are generally presented, they tend to give you a point estimate. Typically, even though they're uncertain, you never, as a user, receive information about that uncertainty. So one common prediction in business that is going to be core to our empirical setting, to our experiments, is how Airbnb gives their recommendations to their hosts about what price to charge. So it tells the host the best price to charge is $180 on September 4th, or February 4th in this case. It doesn't say, but it might be 160 and it might be 200. And even at 180, there's a chance that no one actually buys. Those uncertainties are not communicated. And perhaps that's some of the reasons why we've had this resistance to using AI tools generally, and this one in particular, in the field. So like in the Airbnb context, pricing is a critical task that the hosts do, right? It's arguably the most flexible, the most easily changed. Their income depends on it. Airbnb has an AI that, at least according to Airbnb, if users adopt it, it'll increase their profits. My understanding from what happens at Airbnb is that's almost surely true, at least under a certain set of pretty general assumptions. But lots of people don't adopt. AI adoption is really low in the context. About 90% of hosts do not use the Airbnb smart pricing tool. And so how do we understand this puzzle that AI seems to be this extraordinary thing, and yet in practice, in many, many settings, adoption of AI is quite low. And there are going to be lots of reasons for that. Our hypothesis in this paper is one of the reasons is people has to do with the lack of communication of uncertainty, potentially leading to a lack of understanding or trust of what the AI is really doing. By the way, if you have questions, please ask as I'm going. That's going to be easier. And I should make a clarification. I think it's been, so when I'm talking about AI today, I'm talking about computational stats. So I'm talking about machine learning. There are all sorts of different types of AI in principle, but the reason we have seen this wave of AI attention over the last, depending on how you count, 12, 7, or 2 years, is because of these advances in machine learning and computational stats.
Actually, I have one or two questions
Yeah.
on this slide. First, is the recommendation is usually to lower the price or to increase the price? And the second question relatedly, is it costly or the advice is free of charge?
It is almost always to lower the price, and it is free of charge.
So this was honestly my hypothesis. So when you offer me to lower the price, so I'm somewhat resistant. I guess maybe I'm completely wrong, but if they offered me to increase the price, I would be happy to adopt it much more.
That's a reasonable hypothesis. Actually, in the stuff I'm presenting today, won't be able to answer it because we've mimicked Airbnb in the first set of experiments, so we're lowering. We are currently in the field for the next round, where we're going to sometimes have it lower, sometimes higher, and see how it plays out. But it's not just in the, so in this particular case, the Airbnb pricing tool, that might be a reason. More generally, the low adoption of AI when presented with a point solution in a lot of different contexts, like a point estimate, sometimes it's lower, sometimes it's higher, sometimes it's not even, a lower versus higher, because it's not always about pricing. But I take the point. It's absolutely good. This is a reasonable hypothesis. So what we're going to explore is whether communicating uncertainty might increase adoption and improve decisions. And we're going to run an experiment on Prolific in an Airbnb-like setting. Okay, we've sent this to Peter Coles at Airbnb, and we're hoping to convince him to run the experiments at Airbnb. But in the meantime, what we have are these Prolific experiments to get a sense of how this all plays out. So does communicating uncertainty associated with an AI tool affect adoption of the tool? Research question. And then we're going to do some structural work at the end to sort of back out an understanding of demand. So, and if so, does it improve decision-making? And does it differ by type of uncertainty? So let's unpack what I mean by type of uncertainty. So there's one type of uncertainty, which is the recognition that models are models and they're imperfect. Okay. So this is, your model might be wrong. And in principle, if you had a perfect model, this kind of uncertainty would go away. So this is, I don't have the right variables. I don't have enough data, so my confidence interval is wide. This is, and this, is what we see in Mansky, and also what we see in all sorts of other, like how we think about econometrics in terms of the understanding demand. There's model uncertainty. There's a second kind of uncertainty, which is, we can think of as fundamental uncertainty. Okay, and this is the idea that in a coin flip, really it's either one side or the other, and it's fundamental uncertainty in advance. So we just don't know what can happen. You can't really know how things are going to play out. Some aspects of the universe are just uncertain until they're revealed. Okay, and so these different kinds of uncertainty are actually going to have different implications for how people understand and trust when you're communicating uncertainty. So talk a little about model uncertainty first, or these two kinds of. So this paper came out in the Journal of Refugee Studies, of all places, a little while ago, that pointed out that in the refugee context, the adjudicators are extraordinarily confident in their decisions, but realistically, there's no way they can have any idea about what's going on. Okay, so the adjudicators in a refugee case, the information they have is really sparse. There is no feedback loop, because if you accept a refugee claim, then you have no idea what would happen to the person if they were sent back to where they came from. And if you reject a refugee claim, then there's not really a way to follow up to see what happened to the person after they're sent back. And even then, the feedback loop is in the order of years. And so this is a case where there's just very little information. There's no real way of knowing what would have happened. Okay. So you just don't have enough data to make a good prediction. More generally, thinking that we know from decision theory that decision making is better when you understand that there's sort of different probabilities associated with different outcomes. Whether you're playing cards or rolling dice or thinking about how to design certain kinds of machines. So this is we have a chapter in Power and Prediction, a recent book called Thinking Probabilistically, which is about sort of dealing with what you don't know. So we have these two types of uncertainty. There's the fundamental uncertainty, which is sometimes the world is random. And there's the model uncertainty, which is that if you had better information, you could, that uncertainty would go away if you had better data and a better model. So this distinction is, let's be clear, this distinction is not ours. This distinction has shown up a few times in literature, and Tannenbaum, Fox, and Ullman really sort of summarized it. And they use the terms aleatoric uncertainty and epistemic uncertainty. I think for this audience, you guys would probably like that language. Am I right? I'm not sure. I find it much more intuitive, and most of the marketing and econ audiences find it more intuitive to call it fundamental uncertainty and model uncertainty. Okay. And so because aleatoric and epistemic are just not familiar words. Okay. But if they're fundamental means aleatoric and model means epistemic. So what we're going to focus on here is in the Airbnb context, we're going to sort of communicate uncertainty about demand and uncertainty about the model. Okay. And so, imagine we have balls and urns. Okay. We have in urn A, there's a mix of red and black balls, and we know the mix, half red, half black. And in urn B, we have no idea. So we just don't have the information. It's not fundamental uncertainty. This is model uncertainty. We just don't even know the model. For all we know, they're all black. So you can think about in the context of at what price am I going to sell the unit as a version of the an urn where we know the distribution of the balls, we just don't know what we're going to get, right? So at a price of $100, there is a 70% chance that we're going to sell the unit. Versus not knowing the demand, we're going to recommend a price of $100, but we don't really know if the best is 100 or 110 or 150 or 95. So you can think about different kinds of lotteries, and this is from Fox et al. Same authors in a different order, to understand these dimensions of uncertainty. So, there's a bag filled with exactly 50 black and 50 red, and you can choose the color to bet on. You draw a chip, and if it's the color you predicted, you win. Okay, that's the fundamental uncertainty. The bag is filled with red and black, but you don't know who's red and how many red and how black. So you draw a single chip, and if that chip is the color you predicted, you win. That's both epistemic and aleatoric uncertainty, or model and fundamental. And then the third type, where it's epistemic only, is there's red and black. You don't know the relative proportion. You empty out the entire bag, and if the majority of the chips are the color you predicted, then you win. So that's purely the model uncertainty. You don't know what the proportion is, but if you did, then you have all the information you need. Okay. And so that's how we're going to be thinking about these kinds of uncertainty. We're going to try to map this into that Airbnb context. So here's what we do. So we're going to take this smart pricing example, and we're going to give people a map, kind of like what they see on Airbnb. And we're going to give a number of subjects, about 20 choices each, and the choices are going to look like this. So here's you. You guys can see my arrow? Can you? Yeah. Okay. So here's you. And here's your neighbor's listings. How many beds you have, your rating, and you got to think about what you want to charge. And you have your neighbors charging stuff. Okay. And we're going to vary whether they get an AI recommendation in terms of what price to charge, and different kinds of uncertainty about that recommendation. So it's designed to mimic Airbnb's tool. The control will be what price should you charge? And then there's also going to be a treatment like the Airbnb pricing tool of what price should you charge? The AI recommends $90. Okay. So designed to mimic the tool while allowing us to structurally back out the demand. So the essence of this is, and this is what the actual tool looks like. We're trying to mimic this as close as possible. There's the AI suggests $115, and a lot of people don't adopt. But arguably, if we said, hey, we recommend $150, and there's a 20% chance someone will book at $115, that might lead to a different rate of adoption. Might be higher, might be lower. We think our hypothesis is going to be higher.
Avi?
Yeah.
So it said in the previous slide that there are 20 choices, and these are without feedback, so it's like single shot, or?
Yes.
Okay.
Yeah.
Thanks.
Yeah, we're working on the thing we have deployed right now is to get them to see if it's different with feedback. But it's yeah, then the structural backing out of demand becomes really ugly. We're working on it. Okay. So this 20% demand is going to give us fundamental uncertainty. Okay. And this is what Airbnb is doing up there. This is this broadly, it's related to these two streams of AI work, which is some unexplainable AI. So arguing that we should allow for interpretability, because explainability and interpretability can increase trust. The explainable literature tends not to focus on explaining that the model's often wrong or imperfect. The explainability literature tends to focus on here's the data we use to make our prediction. Here's if you get a recommendation, here's why you likely made that recommendation. Okay, and you can think about, our hypothesis is an important aspect of explainability is explaining that this is computational stats and not really, that has uncertainty. Then there's this literature on algorithmic aversion about all the various reasons people don't like, ignore machine recommendations, where the machine recommendations seem to be clearly better than human. And so this is like Berkeley Dietvorst's work, that people don't choose algorithms. The algorithms clearly outperform. Mike Yeomans has this work with others saying, if people know that it's a recommendation comes from an algorithm, the recommendation itself is less valuable. So this is a really fun paper if you haven't read it. It's about jokes. And so people, the AI joke recommender is better than the machine learning recommender engine is better than humans at recommending what your friends are going to find funny. But if you know it was recommended by a machine, you don't find it funny. And so the machine recommendation engine works only if you think it's a human recommending and not a machine. But there's no uncertainty being communicated there. Then there's work in forecast mistakes and in medical context suggesting sort of various reasons why adoption doesn't happen. So we think by lowering ambiguity, we're going to lead to better decisions. Like first, this is a decision theoretic point, which is that if you understand the uncertainty, you can take that into account and sort of map out the decision tree better as a decision maker. There's also, it makes the strengths and weaknesses of the AI clear, okay? And that actually means, the fundamental uncertainty means you can make better decisions in a sort of pure sense, right? Because that's how we teach decision theory. And okay, well, if you understand the branch of the tree, you're going to do better. They're communicating the model uncertainty. Maybe that'll lead to trust, maybe not. It depends on whether telling people that your model isn't that good is going to make them like it or not. And this is where actually to your earlier question, Ori, the feedback is going to be interesting, right? Well, you learn pretty slowly in this context, so we'll see. Then we're then going to look at this, given what happens, given what people do when faced with an AI with uncertainty communicated, what does this tell us about what the users think demand actually looks like. So because in the back, if the users are choosing price, then presumably to maximize under a profit maximizing assumption, then they're backing out what demand is from a combination of their intuition and from what the AI is recommending. Okay, so here's the experiment. You get this, it's incentive compatible. They're going to be paid a fraction of profit for a randomly selected day. So they do this 20 times, and they're going to be paid a fraction of the profit for that day. So given this information, select a price. Okay, and there's 5 different treatments. There's 5 different arms. There's a control group where they're told to select a price, but they're not given any recommendation. There is a AI-only treatment group where this is quite similar to how Airbnb does it. They're given a suggested price, but it's a point estimate, no uncertainty. There is a treatment with fundamental uncertainty. So they're given a suggested price and they're told the probability of booking. Okay, so this is, look, demand curve slope downward. The higher the price, the lower the probability of booking. So at the AI suggested price, you're going to have a 40% chance of booking. Okay. It's not 100% all the time. Oh, these labels are mixed up. Okay. Sorry, these labels are mixed up. But the model uncertainty is going to be, yes, you have the AI suggested price and you have a range, but you're not told the probability of booking. And the model with fundamental uncertainty, FM, is going to have both. Okay, and then we, we welcome, and we have, I'm just going to walk you through the details here. And we have a, are they paying attention? An attention check. And then we say, you're faced with a pricing problem similar to Airbnb. Want to maximize your profit. Choose the price. You don't want to set too high. You don't want to set too low. Then we give them a practice where here's their listing and here's their neighbors. And we give them sort of information. We ask that you list your price for different days. And then you suggest they keep in mind that they want to make the best pricing decisions. You price one situation at a time. You'll be competing with your other neighbors. Your neighbors don't change because you're in the same place, but the demand for short-term rental can change. And then you paid them to participate, and then we're going to give them a bonus, which is a fraction of their profits. It's a pretty good wage in the end.
Ravi?
Yeah.
Just a short question. So they get the same map and they have 20 decisions with the same neighbors, right?
It's the same map, but the price numbers will change on the neighbors.
But do you have some consistency? Do you have some algorithm for that? I mean, in the sense that the higher price, like the 290, right, neighbor 3, will it always be the highest?
Oh, will neighbor 3 always be the highest?
Yeah, for example.
Not necessarily. But since in this, neighbor 3 is a 5-bedroom, and neighbor 2 is a 2-bedroom in this particular context, neighbor 3 is likely to be higher.
Or in other words, how do you determine the settings here?
Oh.
Do you use real data?
Yeah,
or...
so we've tried to back out. We've used, I forget what it's called, but there's a website that has scraped Airbnb, a whole bunch of data from them, and we're using that to generate simulations.
All right, thanks.
But both of the actual demand, so the demand is based on an estimate, our estimate from that data, and then what the neighbors are doing and everybody's doing is also based on that data.
So the percentage that you give in the treatment, the percentage of getting the price, this is your estimate?
This is our estimate. It's based on a semi-structural, I guess you can call it a structural demand model based on real Airbnb data. Yeah. But it's scraped, so it's not, It's not data from Airbnb, so there might be some things missing. But it's how a bunch of the literature does this kind of thing. Okay. I said that. I said that. Okay, so we give them the test case, AI suggested price. So this is fundamental and model uncertainty. And so if you're in that group, all 20 of your price decisions will also be where will be in the same group. So it's between subject randomization. So this goes on for 20 days where you're given these, here's you, here's your neighbor's prices, etc. And then after 20, okay, you're done. So you see these slight changes. And we ask them a handful of demographic questions. Have they hosted? Have they rented? Education and how they feel about their probability and stats and numerical expertise. Okay. Then we do ask them, what did you use to set prices? So we have these 5 conditions and we run it. Point number 1 is, so we add the AI and prices come down. So this is distance to the AI price. Okay, so this is not actual price, but it's sort of how far off you are from what the model suggests is profit maximizing. Okay, so people, when you add the AI, they listen, okay, somewhat. They move like, a little less than half. When you also tell them the fundamental uncertainty, they listen more. Okay, so they bring the price down even further. So you tell them there's only a 70% chance that this is going to be booked. That increases adoption of the tool. Okay. When you only tell them the model uncertainty, that our best guess is $110, but it might be between 100 and 120, that looks like exactly like just telling them about the AI. That kind of uncertainty doesn't seem to make much difference. And then when you tell them about the model uncertainty and the fundamental uncertainty, again, adding the model uncertainty doesn't seem to make much difference. Okay, at least on the average, we're going to get to that. So there's a subtle difference that's going to come.
I have a question. Is this the absolute distance or signed distance?
This is the absolute distance.
Okay.
Okay. Is there... I assume you had a reason for asking the question. So is that... Okay.
No, the reason, if I understand correctly, is because the Peter's question is whatever they undercharge or overcharge.
Okay. Overcharging is pretty rare. That's why we're just doing absolute distance. That's yeah. So this isn't, if we threw out the overcharges, we get almost exactly the same numbers. It's really, really rare in this data. Okay.
So they usually set a lower price than the price that will be suggested.
Oh, sorry.
The other way around, right?
Flip way around. Yes. The relative to the human, I was thinking you're putting on the human, I was putting on the AI, but the way you framed it is correct. So the human charges more than the AI. And so, yeah, this is, okay, so this is that. And then this is that graph in numbers. So it suggests a difference in price, a difference in revenue, where, and a difference in profit if you believe the marginal cost numbers, that, we told them what the marginal cost is, so they should, but, and there's maybe, if you squint, you can see a difference between model uncertainty. When you add model uncertainty, your revenue doesn't really go up. Well, it doesn't, but your profits do. And that, at least a little bit, and that's not mechanical. So that's like, there's, even though on average model uncertainty doesn't really help at all, it does get rid of a couple of outliers, extreme outliers. So if you tell people an optimal range, they are less likely to be way out of that range, and that affects. So this is that. All right, so you can see trial by trial, when you give both fundamental uncertainty compared to fundamental and model, I'm not sure if you can see, but the orange, this is for the average of the 20 trials. This shows each of the 20 trials separately. The orange dots tend to be more compressed than the blue. So the blue is actually, their average is the same, and that's why the average price is the same. But since profits are, as you go further away from the profit maximizing price, your profits decrease more. You have fewer outliers when you communicate both fundamental and model uncertainty. So this is a subtle result that seems to be there, though. Okay. Now let's assume the subjects are profit maximizing. And so now we can do sort of standard-ish structural econometrics, and with the structural demand model, where the optimal price minus the cost plus the demand over the derivative of the demand is going to be 0. Okay. And that allows us to estimate demand, like what do people think demand is, because we see what price they choose and we know their costs. So we see price, we know costs, and so we can back out theta. We can back out demand. And okay, so this is the numbers. That's not potentially that informative. Like, okay, what do we do with that? But this column is interesting here. So what this shows us is, the true demand, as we've estimated from Airbnb data, has an elasticity of something like -2.3. But when we don't communicate that sometimes people just don't book, the backed out elasticities are bigger than -1 or less than 1 in absolute value, right? Which which then you can start to understand why they're pricing too high. In contrast, when we communicate the fundamental uncertainty, when we tell people, look, there is a good chance this room isn't booked, even though this is the optimal price, then when we back out what their estimates of demand, we start to see much more elastic estimates. So this is, we communicate quantity essentially by communicating the uncertainty of demand. And in the process, the users then understand about elasticity in a way they didn't before. That's how we're interpreting it. And so this, by imposing the structure, what this is telling us is not just that communicating fundamental uncertainty makes people listen more, but it gives us a hint of what they're listening to. They're understanding that that uncertainty. Okay. And we can sort of, like, that was a way to summarize it, but we can do this because we can back out demand for every single trial. And we kind of have to do a trial by trial because then the numbers are different. And you can see that, or maybe you can't see, but it depends how big your screen is, that when we communicate fundamental uncertainty, the demand looks more elastic. Okay. So here, I'll just show here. The AI only, the model uncertainty, and the control, we have these almost linear demand functions. But when we, the dotted, this is true. This is what we sort of estimate based on our data. And when we communicate the fundamental uncertainty, the demand looks a lot more like true demand. So true demand is the black line, at least, because we've simulated everything. So that's the true demand in this model. And when we communicate fundamental uncertainty, then people's demand looks a lot more like true demand. Okay. Next steps. The key next steps we're about to deploy again, although based on feedback here, we may tweak this, to allow for learning by feedback, from feedback, so that we can say, we can sort of understand when the AI, in some sense, is right versus wrong, how that changes trust, how that changes usage. And also we're going to add this, everything here was lower, and we're going to mix some high and low to get a sense of whether it's just that people are learning to price low, or whether people are learning to listen to the AI. The starting point here was that when we talk about AI, we should think about it as computational stats. Okay, no surprise to this, to you guys. But that means AI's predictions are going to happen with error, and it is a design decision whether to communicate that error or not. Okay. Most of the AIs you use do not communicate the error. ChatGPT is extraordinarily confident. Okay. For the most part, all the other AI tools that you interact with give you a recommendation without explicitly recognizing that uncertainty, which is, by the way, a little bit different from the first generation of commercially deployed AIs like Google Search, which had 10 blue links and explicitly recognized that the first link might not be the right one. Okay. Now, there's these two types of uncertainty, and we're thinking about how communicating these different types of uncertainty affect results. Let's open it up for more questions, and then I guess your norm is more questions, then relaxed questions, right? So.
Thank you. This is very interesting. And now, as you suggested, we open the floor for questions, and I think Kinelit is the first one.
Yeah, I just wondered how long gonna people trust the fundamental uncertainty that you present, right? So you say a number, but that's like a fact. So there is a meta uncertainty about the uncertainty that you present.
Sure. Yes. So there's a do they really believe my model? So what I think is interesting is they listen. So in some sense, they're believing the model more than when we don't communicate that. But when we communicate that and the model uncertainty, communicating the model uncertainty doesn't seem to make much difference. So I think it's that's a long way of me saying, I don't know. I think in our next round, when we start to look at what happens with feedback, that will help, because we'll get a sense of whether, when we say 20% chance of booked and it doesn't get booked, does that increase trust? Where when we say 90% chance of booked and it doesn't get booked, does that decrease trust? And we'll have enough data, I think, to be able to unpack those kinds of questions. It's a great point, though. Thank you.
Doron.
Thanks, Avi. I have a question. I don't think it directly relates to your experiment that you showed, but have you considered also the competition and your beliefs about them? So, for example, is there equilibrium where if no one uses an AI, maybe I shouldn't use one, and if everyone uses an AI, maybe I should use one?
Yeah, the right way to put it. I've considered, yes, it's a really interesting aspect of the whole thing. And I think one of the reasons why people don't trust Airbnb is because they don't know if Airbnb is helping them or helping the platform. And so which is partly about competition, but partly about the incentives of the platform versus the incentives of the individuals. We're not, in this particular experiment, we're not unpacking that, but there is a bunch of work on sort of equilibrium recommendations of a platform, and the push, that leads to a different result. So that literature tends to say the platform should help people collude. Okay. So the platform should figure out the profit maximizing price if it's a dominant platform, I guess, and help people collude and keep prices high. Although then there's like a follow-up to that. I don't know if you know the two-sided platform literature, but it gets complicated. So if really what the platform is trying to do is get users and not hosts, then the platform's going to push all prices low. And that's, I don't know if you've seen the, platform economics tend to have so many equilibria that it's very hard to get a solid prediction off those kind of models. But it's a great point. Thanks.
Ori.
Thanks. Yeah, so from my understanding of the algorithm aversion literature, the phenomenon of algorithm aversion is algorithm aversion in recommendations of humans versus recommendations of algorithms. It's not so I think that you're not making the comparison to recommendation to other types of recommendations, right? And this would be algorithm aversion, because what you try to say here is algorithm adoption. So can I increase adoption of an AI recommendation, but maybe people are already adopting it very nicely, much better than they would adopt a recommendation from other experts, humans, for example. So maybe does that make sense?
100%. So yes, we are comparing, do you use the algorithm versus do you trust your own human judgment? And your point is, yeah, that's a useful distinction. Thank you. I'm going to make sure that's clearer. So I agree that it's not about another human versus a machine. It's about yourself versus machine.
Yeah, and in those cases, well, so people value their own opinions.
Yeah.
So is that really algorithm aversion, or you're not trying to make the claim that this is algorithm aversion, maybe?
No, I think it's or let me say, I'm kind of indifferent to whether we want to call it algorithmic aversion. I think it's a reason why adoption is relatively low. And that's a lack of trust in some sense. Whether that's from the, I don't have a strong opinion about what the right label is. Although the algorithm aversion, like the only where the label really plays out is who my referees end up being. And who ends up reading it based on the keyword string. So we're going to think about that, but thanks. Okay.
Peter.
Okay, then I think the only relevant criterion of the information is which gave the highest profits. So could you repeat which gave the highest profits? And do you agree with me that that's the only relevant criterion?
Yes, I agree. It's the only relevant criteria. The one that gives the highest profits is communicating fundamental uncertainty gives substantially higher profits than anything else. When you communicate fundamental and model, there's a little bit improvement by having also model, because you lose a couple of outliers. But that improvement is actually, well, we'll see as we add more data in the next round, whether that becomes statistically significant or it was an anomaly. But my intuition is that'll remain, which is by communicating essentially a confidence interval, you're getting rid of a couple of outliers, but most of the action is happening from the communication of fundamental uncertainty, at least what we have so far.
Okay.
Lalitza.
Thank you. And my question actually builds on Ori's question about algorithm aversion. And I was just thinking whether the framing of the suggestion would matter. And that would be not only comparing your judgment to the algorithm, but if it is something like our AI agent recommends this price, blah, 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 versus based on past demand, our engineers recommend something.
Okay.
So if there is, because you know, the discourse about AI very often is framed into in negative terms. What people listen about AI is quite negative. So if there is some fundamental aversion about AI, and this might,
I think that's
to low adoption. I don't know.
No, okay. I think that's a great point. So here's how I think about our contribution, and then I want to think about where what you described fits in. So I think of our contribution as comparing the AI only versus the AI plus uncertainty. Okay. Now, you're suggesting on the AI only treatment, we could call it an AI, or we could call it what it really is, which is, you know, a team of engineers who design the AI. Okay. So the question is, oh, I like this. Okay, so if we communicated so there's one question, which is, if we call it a team of engineers, would adoption be higher? Okay. But then there's the question that this paper is about, which is, if we call it a team of engineers, are we going to see a difference between communicating uncertainty versus not? That's a great question. I have no idea what the answer is. So I think I gotta, is there a literature on that you know of, or no? Okay, so I gotta dig in and see.
No, I mean, it would be more around the framing, the framing literature. Yeah.
That's great. Thank you.
Mandeep.
Hi, thanks, Avi. You can hear me, yeah?
Yes.
Okay, great. So your work reminded me more about advice seeking. It relates to the advice seeking literature. So whether someone actually goes with their own viewpoint, sorry, or seeks advice. In this case, you're talking about algorithmic advice. And there's some literature there talking about when the advisor sort of presents the advice, but also uncertainty or confidence around their advice as well, and how the individual deals with that. So that's one area I think that you could link into usefully, and maybe more directly relevant than the algorithm aversion literature, actually. The other thing is also then that relates to how the uncertainty is communicated. So there's a whole literature around how you communicate uncertainty, whether it's verbally or numerically and so forth, can have an impact on how you think about the information that's being communicated, and also, in this case, the advisor. So you might want to look at that as well, because I think you weren't clear. You used words. You said good chance.
Yeah.
Yeah, so you might want to, that's a whole literature as well. So there's two other literatures I think are very directly relevant to what you're doing, more so than I would say than the algorithmic version literature.
That'd be great. Can you give me a couple of classic sites, or a couple of sites that I can then?
Yeah, so, yeah, I will email them to you.
Okay, thank you.
Ido. We don't hear you.
Just a thought that is not exactly your main topic, but my intuition is that people like me, so I have one subject, you know, when it's come to Waze, I'm adopting with very high probability. If I do open Waze, I typically adopt, and I'm not concerned at all by the fact that they don't give me variability or uncertainty there. And here is one random thought about so for why this could be different from this and that. So I think that what happened this is my guess, that maybe what happened with Airbnb is that if they recommend 110 and you say 112, most likely you're gonna win. You're gonna gain another $2. You know, because they select it in a way that you know, maybe you reduce your chances from 80% to 75%, but still 75% of the time you will be happy, even more. Right? It's almost always you will be happy if you don't get it. So it could be that this phenomena happens because bidding in this specific environment, bidding a little bit higher is better most of the time. Whereas with Waze, when I do something that they do not recommend, I'm typically sorry. because they tell me how much time the two routes is, and when I select the one that they say more, typically it is more. And then for a while, it of course happened to me several times. I drive in the other directions, and they tell me, "Oh, we should go back," and the time for my route is always better. So maybe if you look at people past experience, and this is why your feedback experiment will be good, you can find that it's not something. There may be something here more like the basic learning research that people in this community do.
Okay, absolutely. So it does matter for their profits, like, because there's, the demand curve is elastic. So they might not intuit it because $2 versus 5%, but they would be losing money if they price too high. So I how do they interpret that as a fair point? But it's like, and then in ways I'm not convinced. So maybe you're right that we don't want that we don't really care that they don't communicate uncertainty in ways. But I don't know. For me, I'd much prefer it to say, okay, this route is going to take you between 25 and 35 minutes. And that route is going to take you between 15 and 60 minutes. Are you willing to take the risk that it might take 60 minutes? Like that? Because my experience, Waze doesn't work that well in Toronto, but Google Maps works okay. But every once in a while, it's really wrong. And I'm like, I just should have just gone the way I always know. And so I do think uncertainty communication in all sorts of places would be useful. Another one is like Uber. Uber tells you how long the wait's going to be. Now they give you a point estimate. That point estimate, they deliberately, as I understand it, give you a lower estimate of the wait time than is real. But maybe some uncertainty would increase trust in the algorithm. Maybe not. I don't know. It's an empirical question.
But this can be tested in experiments.
Yes.
And basically, my hypothesis that I can predict under which situation adding the uncertainty will work.
Yeah.
But this is really interesting, open future research. It's not.
Yeah. No, it's an interesting set of questions. Thank you.
I hope I pronounce your name correctly, Sephir.
Yeah, it's actually Sapir, but it's okay. Thank you.
I'm sorry.
Well, no worries. Well, thank you for a great talk, first of all. I just wanted to add to Ralitz's point, because you asked for the literature. There's, I think, one paper from Jennifer Log of Georgetown University called Algorithm Appreciation. And that is exactly, I think, the opposite of what we think intuitively about this. And she and her colleagues show that when we label something as coming from AI, people show a higher tendency to rely on that rather than when it comes from a human expert. And I truly like to see how your experiments turn out in this regard, because the tasks they use are quite different. And I think your tasks are more relevant to real world scenarios. Yeah, I just wanted to add that.
Interesting. Okay, I'll check that one out. Thank you.
Can
You're
I
welcome.
also ask something? I'm so sorry I couldn't somehow raise hands.
No worries, go ahead.
Jada. Thank you very much. Actually, like what Sefer said, maybe we are believing in AI quite a bit. And when they say, for example, when they offer a price, we think, if I give this price, it's like almost 100% that my flat will be rented. But still, I am ready to take some risks. And I'm ready to put a higher price, but maybe it will be rented later, or I want to try the 80% chance whatsoever. So what I wanted to say, maybe, it's not just the uncertainty knowledge that increases my trust in the AI, but I already trust it but with this extra information, you are giving me more knowledge. So you are reducing the knowledge deficit, and there is a knowledge deficit theory, so that, you know, I'm acting more in line with the experts.
Yeah. Okay, so I think that's exactly what's happening. So if you think what we did with the backing out demand estimation, the extra, by communicating the uncertainty, people actually understood better, at least based on their actions, what real demand looked like, the shape of the demand curve. And so I haven't heard the expression knowledge deficit theory, so I got to go look that up, and I will. But that, yeah, it seems very much consistent with where we ended up landing. Exactly. So thank you.
You're welcome. It's knowledge deficit theory.
Knowledge deficit theory.
Yeah.
Got
Okay.
Okay, guys.
I'm just
thank
thinking,
you.
can I just add one more thing? I was just thinking that also the recommendations literature might be relevant about the mechanisms, because, you know, if you compare the in the early stages of the recommendation agents, the algorithm of Netflix, that would be based on your preference, here are the movies that you would like, as opposed to Amazon, which was people who have made these purchases have also made these other purchases. And I think there are some papers that show that actually this one works better than just based on your purchase and the comparison to the algorithmic comparison to to the characteristics of the product. Yeah,
for sure. Thank you.
Thank you, Abby, for
you
the
guys
great
longer.
talk. And now the formal part is over, so we'll have to end now. But those who want to stay and have other remarks or questions are welcome to stay with us, if it's okay with you, Avi, for additional 10 or 15 minutes.
Yeah, absolutely. Happy to stay.
Thanks, Abby, for this interesting talk, interesting topic, and nice study. I really like it. I have to go though, so I do have a few questions, so I'll try to email you.
Okay, yeah, please just email. And thank you everybody so much for taking the time. I really appreciate it. I got, like, the paper will be better because of this hour for sure. And that's fantastic.
Happy to hear that. It's better than the reverse, if it's getting worse. I hear that it happens quite often in marketing, unfortunately. So that after the review process, the papers are getting worse than before the review process.
For sure.
I'm sorry, I'm not putting my camera on. I've got doing childcare at the same time. I find it was interesting that you pointed out, you know, how different disciplines rename concepts because they don't understand the name used for, and I find that really annoying and very confusing. And I was thinking, how come we only do this in the social sciences and they don't do that in sort of the hard sciences? They don't just go around renaming things as often as we do, because it's really not useful calling something fundamental versus model uncertainty. When, for example, when we're not talking about models in particular, or, you know, and there's obviously some fundamental uncertainty, one might argue that's a very vague term. The reason I'm saying that is because it just confuses me. It confuses the people I talk to. So I've just dropped you an email about this stuff. And the reason I came to a talk, Alvi, was because I've done some work on communicating uncertainty and some work around AI recently, looking at how basically NATO personnel think about AI. And I just, and this week I'm going to go and teach on the NATO Defense College about uncertainty, and it's just very confusing to them. And it's very confusing to me. I've had to like throw out so much stuff because all the different words for uncertainty, let alone trying to figure out what it means. And then how do you communicate the uncertainty in your uncertainty assessment? So how are you going to tackle all of these? I mean, do you even want to go down that road? I just think there's many other things you could do beyond thinking about the uncertainty necessarily in the algorithm, if that's really the fundamental thing that's stopping people from using the advice.
So, oh, that's lots to unpack there. So actually this literature, this whole line of thought came from a talk I actually gave at the NATO Defense College back in 2019 that led to some work with John Lindsay and some others on AI strategy with an emphasis on how do humans interpret the information coming from machine recommendations. It was the core point that kept coming up was this distinction of machine decision making, and this is a little bit sort of academic, but I don't think machines make decisions. I think humans make decisions, and machines allow a change in the time and place of human decision making. What do I mean by that? Is in prediction machines, we distinguish between these ideas of prediction and judgment. Okay, so prediction is the probabilities, and a judgment is your values. Like, what do you do given two different probabilities? So the judgment are the payoff at the end of the decision tree. And when you automate something, you're pre-specifying what to do given any prediction. And so that, understanding that distinction means that if you're going to automate, you need to embrace the uncertainty and anticipate that what happens when you're wrong in different directions. So like you need to walk through the whole decision tree. So that like underlying this, John Lindsay and I talk about this in a paper we have in International Security on in military decision making, but we also talk about it in all sorts of other contexts. Now, so that was your second question. Your first question was relabeling. I think scientists relabel too. I don't know if you've dealt with stats, but the things that Bellman equation is a Bellman equation, but the rest of like statistics, we use the same labels. We use the same math with different labels all the time. And so I would argue that what matters is when we're talking about model uncertainty versus fundamental, or epistemic versus aleatoric, as long as the math is the same and we describe it in the same way formally, then in different languages and in different cultures, we'll use different labels. And I think that's okay. But that's my perspective. Like, not a philosophy of science expert, but at least I think we can communicate with each other well, as long as I say something like, okay, here's what I mean in the underlying math. But okay.
Yeah. Maybe there is a paper by Gary Bolton and Elena Katok in Management Science recently, well, maybe 5 years ago, that's showing that people prefer experts that provide probability estimates. So this could be related. But we have a result that kind of challenge their conclusion, but we didn't study probability estimate. We have a paper on how people make decisions from valuation, and we give people in the lab 2 valuations. They have to choose between whether to take a lottery or take the status quo. And we give them 2 evaluations of this lottery. One is the expected value, and the other one is the median of the binary lottery, which median is also the mode. In our settings, people prefer to go with an expert that the experience leads them to stop trusting the expert that provides expected value. So it's not exactly, it's not exactly, so it's kind of contradict the Katok and Bolton, one of their explanation for their story. Their story is, they called it cry wolf effect, which could be related to what you're saying. So if I tell you something and you know that, and then then that didn't work, you say, oh, you can ignore this guy. But if I give you a probability estimate, maybe it makes sense. But this cry-wolf effect is inconsistent with our results. Anyway, just random thoughts.
Can you send me the paper, or do you mind?
Well, I can send you our paper that cites their paper. Maybe I can also find their paper.
No, their
We will
paper I can
those
find. I want your
papers. We
paper.
know those
Okay.
papers.
You know, I'll send you our paper. Yes.
Okay, thank you.
But if Fim gonna come, he can bring it directly in our copy, the old style. But I'll email to you.
Okay.
Yeah, this was really interesting. I'm fascinated by the fact that I trust Waze, and I think many people in Israel trust, to the extent that now, because of this stupid war that we have, Waze doesn't work. So many people stay at home. So this is one of the main costs in Haifa. You know, in the northern Israel, there is a more larger problem, but northern Israel, but in Haifa, it's mostly so far only the Waze.
Waze is.
But soon enough, it's going to have other costs.
Okay, well, that's good to hear that. I guess. Any other